In this case, we've been asked to solve an equation, and factoring is a good way to get zeros. But in order to be able to do a factoring where a is not equal to 1, in this case it's 2, box factoring is the way I always go. I know that the first component of my box, upper left, will be 2x squared, and I know the bottom right will be -6, and I have to choose things that could get 2x squared, so one of them has to be 2x, and one of them has to be x. 6, we could have 3 times 2, one's got to be negative, one's got to be positive, or I could have 6 times -1 or -6 times 1. Knowing that I need a positive 1 in the middle, I'm going to try the 3 here and the 2 here. 2 times 2 is 4x. 3 times x is 3x. These are off by 1. I know I've got a positive, so I'm going to say, hey, this must be a negative, making this be a negative. And now when I add my middle terms up, 4x and -3x make 1x. So I know I've correctly factored 2x minus 3 times x plus 2 equals 0. Well, as I set each factor equal to 0, this factor is x equals -2, and this factor is a little harder, 2x minus 3 equals 0. Add 3 to both sides. 2x equals 3, divide by 2. X equals 3/2. So my zeros are -2 and 3/2. They wanted the one that was greater than 0. X is greater than 0, so 3/2 is the right one. But the key, box factoring, a is not 1. When you factor, make sure you multiply back. Your two factors should give you what you started with. I saw a lot of tests that had x in the first term and x in the second term. X times x could never make 2x, so that should have been an easy check that you had made an error.